Hey, real quick, let's go over some graphing tips. Most likely your graphs are going to be on paper 2, which is in 2 days. And it's loading. Still loading. And it's here. Okay, we absolutely are going to need a ruler and a pencil. Ruler and a pencil. Calculators are also good for this because it'll help you kind of figure out the scale that you need to have so that all your numbers fit in. Okay, so we went over this beginning of your class, the beginning of the semester. When you are showing your data or showing any kind of units, you're going to say the quantity or whatever you're measuring and then the unit that it's measured in. So like time, you put a slash, and then seconds, or time slash, and you're going to put a year. In the tables, and this is what I have in red, the column of the table will have the quantity of what they're measuring and how they're measuring it, the unit that they're using. You could say, if the example was like they have meters per second, you could literally write in meters, P-E-R, second. You could put M, P-E-R-S. You could put M/S, or MS to the -1, which is the same thing as having it in a fraction. Okay, and then we can take what's in the data table and immediately put it right on the axes of your graph. I'll show you that one here. So we've done this before, the age of the whale carcass. Remember, this is always your X, and this is always your Y. How does the X affect the Y? How does the age of the whale carcass affect the number of species on there? And then if you're somebody who's like, cool parrot, but I don't know what's the X and what's the Y on a graph, remember your Y has a long tail, and so the X is just going to be the remainder of it. But we're able to take exactly what's here, and it needs to be exact. I stress this so much, yet it still isn't done on exams. You won't get any marks on your labeling your axes if you don't do it identically. This is the time to plagiarize. So literally, age of the whale carcass in months, right here on my X. You don't want to just put age of whale. It's carcass, and it needs to be months. The amount of species that are on the whale carcass. So number of species on the whale carcass, identical to what you see on your data chart. All right. And the same thing here. This one was the bar graph for the different coral species at the depth of 4 meters. And so this one, just to talk about the putting the labels on the data table immediately on the graph, it said draw a bar chart, show the number of each coral species, so how many of each species is going to be at the depth of 4. This is something they would have used random sampling for with the quadrat. The quadrat would have measured anywhere from 0.25 square meters to 1 square meter. Remember, it is a square, so you want to put the square unit there. Okay, so at the 4, here's your depth. Now, some of you guys did this incorrect because you wanted to put depth on here. I get it. But you're not showing species at different depths. The depth is the same. That's it. It's almost like in one bag of M&Ms, how many of each color do you have? So my 4 meters is my one bag of M&Ms, and then the colors are going to be the species. And so it's what are you testing, and then what are you measuring? Like, how do you, the measurement or the responding variable, remember dry mix, the dependent responding or the answer, whatever you're measuring, that goes on the y-axis. And then the manipulated independent variable goes on the x-axis. And to manipulate something is to change something. So they're not really, they're not physically changing anything. They're just looking at different species. And then what's their answer? What would the response be to this? Well, if I said how many species are How many of species A do you have a depth of 4? If somebody asks you how many, you're going to have to count. Like, that's how you get that answer. So that goes on the y-axis, the response. And so that's going to be the actual amount. So the number of coral colonies is going to be my y. And then each different species is the x. And we wanted to say, like, these are all different species. Sometimes you just might put A, B, C, D, E, F, and you don't put anything below it. And so then I would say, what are these? Like, what are these representing? What is A? What is B? And so that's how you can get that one done fully. Okay, down to the purple part. So the independent variable, like I said, is on the x-axis. I teach my students dry mix, the dependent responding variable on the y-axis. The manipulated independent variable goes on the x-axis. Each axis is going to have, just straight from the data table, whatever they're measuring and the unit they're measuring in. The graph needs to be at least half the space or more. At least half of your graphing space or more. And the way you can get that done right is by looking at your scale and your data. You know, what's your biggest data number? So if we are looking at one of the examples I have, this was the number of species on the carcass. So my biggest number here is 50. If I wanted to push my y up to like 150, well, then I would only be using a third of this area. Even pushing it up to 100, you'll be using like I bet half the space, but it just doesn't look right. It looks like you didn't plan your graph out right. It just doesn't look complete. So I always just count like how many like quadrants I have and then divide it by my biggest number. If that ends up being a fraction, like if it ends up being like 9.7, I'm just going to round that to 10. Like, just going to go up to the biggest one. And then once I have that, and you guys see me do this, I'll say, okay, well, my biggest number here is like 5. That's where I'm starting. Not my biggest number, but that's where I'm starting counting with. And I have 5 lines in between to get there. What's 5 divided by 5? Or what does each box represent? Which obviously is going to be 1. That's easy in this example, but it's not always like that. Sometimes it's 0.2, sometimes it's 0.5. Okay, so yeah, the graphs need to be at least half the space or more. Points. For points, they have to be an X or a dot with a circle. If you notice that you're just making dots, like we've pretty much always done until you've gotten into a Cambridge class, put a circle around it. You can also do an X. Or I'm sorry, a cross, a plus sign. And then if you are putting multiple lines or multiple curves on one graph, we're going to want to make a key for that. And so you might say things that have a dot with a circle are species A, whatever it is that you're talking about, and ones that have an X are going to be species B. When you do graph those lines, maybe you could also do species A has like a dashed line while species B is a solid. Do not differentiate your graphs by color. Do not use color. Thank you. Okay, and then we have to use a ruler for everything. For everything. For every straight line on every line you're doing on a graph. Use a ruler or you will lose a mark, and that's 25% of it. Just use the freaking ruler. Come on. Okay. Ruler at the top on a bar. You could even do ruler on the bottom if you want. On a bar graph that has like something that's a 0, I usually just put a flat line there, just so it looks like you accounted for it. Remember how weird they are about having zeros down here at your origin. Put the 0 there, or you don't get the scale, like the labeling the scale mark. Do not connect. If you don't have data for 0 or anything in between that, do not assume it. Don't connect it. If you need to jump in on your scale, like make it bigger actually. Maybe starting with 5 is too small. Maybe you need to get to 50 first. Then you're going to do a little Harry Potter zigzag. And then we would start here with 50. And that just shows that there's a break in the graph. That's how you do that. Okay, and then the last graph we need to know about is going to be making a bar graph. Okay, bar graphs are actually, in my opinion, I think it takes a little bit more time than just doing a line graph. But for a bar graph, this is when one of your data is not numerical. So like species, that's not numerical. Species A isn't a number, B isn't a number. So those are just kind of like categories. And it's qualitative, it's not quantitative. But these need to be equally spaced apart. They do not touch. Equally wide and narrow blocks. So not just straight lines up. They can't touch. Histograms touch, but these don't touch. We don't draw histograms or pie charts in here. But they can't touch. So equally wide and then equally spaced apart. And this is where your pencil is going to be extremely handy. I always will just kind of block out and plan out where I'm going to put them before I make anything official. Now, if you guys are realizing, like, why is this graph so difficult? Why do I feel so dumb? Please read the top, because many times it might hint to you what kind of graph you need to do. And sometimes when graphs end up seeming to be really difficult, you're just doing the wrong one. If you're trying to do a line graph, but it should be a bar, and you're like, I don't know, like, how do I count by A, B, C, D? You can't, because they're not numbers. Like, they're not numbers. So that's not going to work. Read the top, because this one says draw a bar chart. This one says, on the grid, plot a graph. Join the points with ruled straight lines. Please use a ruler. Use a ruler. Use a ruler. And then that's it for graphs. We need to have the labels identical to your data chart. Your scale needs to be in like an even increment. So here I'm counting by 5s, and I continually count up by 5s. The scale needs to be made so that you're using at least half of the space or more. When you're doing points on a line graph, you're going to do a dot with a circle, or you can do an X, or you can do a plus. Occasionally, you might get something where you have 2 very different numbers together. For example, what if it said age of the whale carcass in months, number of species on the whale carcass, and then what if next to it said like number of species on a shark carcass? I don't know, like something else. And if those numbers are so different, then you might need to make another axis right here. If you're comparing like 2 different things that have extremely different numbers. Otherwise, if their numbers are pretty similar, you can keep it on the same scale, like on the same axis. You're just going to differentiate your lines that you make based on like the texture of the line. Is it just solid, or is it dashed, or are you doing it with a dot and a circle, or an X or a plus? Please don't use color. Getting your points in the right area is another one of the marks. Using a ruler is another one of the marks. Getting them in the right area. Remember, you need to be pretty perfect. You can't guess, and that's why it's really important that we know what each box is worth. You can only make half of a box mistake, plus or minus half of a box mistake, which pretty much means you can't make a mistake. but y'all got this. And you guys always ask me, it's okay if a line or a point is on the or is on an axis. That's okay, as long as it's in the correct place. Otherwise, it's okay. You can have a bar touching an axis. It's fine, as long as the numbers are correct. It's okay if it touches the axis. But don't just assume to connect a line to the origin because it looks incomplete to you. If you don't have the data, you don't have the data. Okay, you guys are going to do great.